दोस्तों एडू9 चैनल पर आप सभी का स्वागत है। तो आज ग्रुप थ्योरी का कुछ प्रॉब्लम्स यहाँ पर डिस्कस किया जाएगा। द फर्स्ट प्रॉब्लम इज एग्जामिन इफ द फॉलोइंग सिस्टम इज ए कम्यूटेटिव ग्रुप और नॉट। वहां पर एक सिस्टम प्रोवाइड किया गया, उसको ग्रुप हो रहा है या नहीं, और वो अगर ग्रुप हुआ तब वो कम्यूटेटिव है या नहीं, इसे हमें टेस्ट करना है। इसके लिए सबसे पहले ये देखना होगा जो सिस्टम हमें प्रोवाइड किया गया, दैट इज Z naught. Z is the set of all integers and naught is defined by a naught b equal to a plus b plus 1, where a and b both are integers. Now we have to check first that the system is a group. If it is group, then we are going to check whether it is commutative or not. So for this, first of all we have to prove the four important considerations, that is four important results which is required to prove a group, that is closure property, associativity, identity and inverse element. So first of all, for closure property we consider two elements arbitrarily from the Z set, and then a naught b is defined as a plus b plus 1. We know that a and b both are belongs to Z. Then addition of these two integers will provide another integer. Then the addition of 1 with a plus b also provides an integer. So a naught b must belongs to Z for all a b belongs to Z. Therefore Z is closed under naught. Now the question is whether this is associative or not. For this we consider three elements arbitrarily from the Z set. Now a naught b naught c, this we have to calculate. The value of a naught b is a plus b plus 1 naught c. This is an element of Z and this is another element of Z. So this can be applied a plus b plus 1 plus c plus 1, which means a plus b plus c plus 2. Again a naught b naught c is equal to a naught b naught c का वैल्यू है b plus c plus 1 and a naught b plus c plus 1 means a plus b plus c plus 1 plus 1. This is the definition of a naught b and this is applied here. So this becomes a plus b plus c plus 2. Therefore a naught b naught c equal to a naught b naught c. This holds for all a b c belongs to Z. So we can see that the associativity of this system holds. Therefore associativity holds. Now our target is to prove identity element. So we consider an element. Let us consider elements E and E dashed in G such that a naught E equal to E dash naught A equal to A for all A belongs to Z holds. Suppose this relation holds. So a naught equal to a implies a plus e plus 1 equal to a, which implies e equal to minus 1. Again e dash naught a equal to a implies e dash plus a plus 1 equal to a, which gives us e dash equal to minus 1. So from this two we can conclude it that identity element of the system is minus 1. That is, here E is the right inverse and E dash is the left inverse of the element, right identity, and E dash is the left identity of the system. So each of those identities, that is right identity and left identity, both are equal. So this will be called as identity element, and here identity element is minus 1. And now we have to conclude about the inverse element's existence. So for this we can see that suppose A dash and A double dash be two such elements that A naught A dash equal to A double dash not A equal to identity, that is -1. This holds. Now A naught A dash equal to -1 implies A plus A dash plus 1 equal to -1, which provides us A dash equal to -2 minus A. Again A double dash not A equal to -1 gives us this implies, therefore the right inverse and left inverse is -2 minus A, and we have to ensure that this element, that is -2 minus A, must belongs to Z. If it does not belongs to Z, then it will not be the inverse element of A. So इसके लिए -2 is an integer, again A is an integer, so -2 minus A obviously is an integer. Therefore the inverse of A is -2 minus A. So Z naught is a group, and now we have to establish the commutativity of this system. For that, A naught be equal to A plus B plus 1, which also can be written as B plus A plus 1, which means B naught A, and this result must hold for all AB belongs to Z. Hence Z naught is a commutative group. हमारा नेक्स्ट प्रॉब्लम है, प्रूव दैट ए ग्रुप G naught is abelian if and only if A naught B whole inverse equal to A inverse not B inverse. Abelian means commutative group, मतलब कोई भी commutative group के लिए ये result must be hold. That means if G naught is commutative, then this result holds, and also if this result holds, then the group G naught is commutative. We have to establish that. So first of all, we have considered that G naught is an abelian group, that means a commutative group. So what is the condition of commutativity? Commutativity का condition है A naught B equal to B naught A for all AB belongs to G. तो ये relation हो गया. अब ये proof करना है कि A naught B whole inverse means A inverse not B inverse. For that, A naught B inverse equal to B naught A inverse. How this is possible? Because we have G naught is an commutative group and A naught B equal to B naught A. We have substituted that value, and we know that B naught A whole inverse means A inverse not B inverse. So this is the proof. And conversely, we consider that this result holds. That means A naught B whole inverse equal to A inverse not B inverse. This result holds. Now we know that A naught B whole inverse equal to B inverse not A inverse. This is a common result in any case, in any group. So we have applied this. Now from comparing these two results, यहाँ पर A naught B whole inverse का वैल्यू है inverse not B inverse, यहाँ पर वैल्यू है B inverse not A inverse. So दोनों को इक्वेट किया जा सकता है, इसीलिए इक्वेट की, and then we have take inverse of these two elements, because this is an element of the group G and this is also an element of the group G due to the closure property. If this is an element of group G, then we can take the inverse. Also we can take an inverse of this element, and taking this inverse we have also from the property that A inverse not B inverse whole inverse means B inverse inverse not A inverse inverse, and we know that B inverse inverse means B, A inverse inverse means A. So from this B naught A equal to A naught B holds. So G naught is an abelian group or commutative group. This results also holds.